Three-Eye Atlas. Truth revealed. Whatever you've heard is lie. This is the actual reality of mysterious Comet. What if I told you that everything you've heard about Comet Three-Eye Atlas until now might be a lie? That the story that blew up online, the mysterious lights, the China theories, the alien whispers, all of it might just be the surface of something much, much deeper. Because what you're about to hear isn't social media hype. It's what astronomers, space agencies, and governments aren't exactly talking about publicly yet. This isn't just another rock passing through the sky. Three-Eye Atlas isn't your regular Make-A-Wish comet. It's the third known interstellar visitor ever recorded. The cosmic equivalent of a stranger walking into your neighborhood uninvited from another galaxy. Before it, there was Oumuamua, the long cigar-shaped mystery that some scientists literally called a possible alien probe. Then came Borisov, a frozen gas ball speeding through like it had somewhere to be. But Three-Eye Atlas? This one feels different. Here's the part that makes it wild. Three-Eye Atlas wasn't even supposed to be visible when it was first spotted. It was faint, quiet, tucked away near the sun, then out of nowhere its brightness exploded, glowing like a green ghost tearing through space. People from China to California looked up and thought they were seeing something impossible. And within hours, the internet turned it into a digital bonfire, and theories, fear, memes, everything. Now, you might be wondering, how does a space rock go from a blip on a telescope in Hawaii to a worldwide obsession with millions of views? Why did the first viral footage come from China? And why are some scientists acting unusually quiet about it? Is it really just frozen dust from another star system? Or is there something about its behavior that doesn't add up? Think about it. It's moving faster than most comets ever observed, with a path that suggests it came from outside our solar system, cutting through our cosmic backyard like it knows exactly where it's going. And when scientists tried to trace its orbit backward, it didn't line up neatly with any known system. It's like it appeared out of nowhere, as if space itself threw it at us to see what we'd do. Now, before you jump to conclusions, no, NASA hasn't called it alien tech, and China hasn't claimed it as part of any secret mission. But the timing, the videos, and the way both nations started talking about deep sky observation projects right after its discovery? That's the kind of coincidence that makes you raise an eyebrow. So let's strip away the rumors, the clickbait, and the chaos, and actually find out what Three-Eye Atlas is, where it came from, and why some people in the astronomy community believe it could change what we know about interstellar visitors forever. Because if the data holds up, if this thing really is what it seems, then Three-Eye Atlas might not just be another comet. It could be a message in motion carrying the secrets of another star system. And we've only just begun to decode it. The explosion. The night it began, nobody expected anything unusual. It was just another quiet evening in early October, the kind of night sky astronomers call stable, meaning no solar flares, no meteor showers, no fireworks from the universe. But then, somewhere above eastern China, a faint green spark appeared. At first, it looked like a trick of the lens, a simple reflection from a passing satellite. Yet within minutes, it grew brighter, stronger, almost alive. A few skywatchers noticed it first, then dozens of cameras turned upward. One clip posted by an amateur stargazer on X, the platform once called Twitter, would change everything. The short, shaky video showed what looked like a glowing orb carving through the darkness. No sound, no context. Just that strange light moving with purpose. Within an hour, it had over 500,000 views. Within a day, 10 million. That single post turned a distant, unremarkable comet into an overnight global mystery. And just like that, the internet did what it always does best. It lost its mind. People called it everything from a new Chinese satellite test to an alien craft. Hashtags like More Atlas Comet and Our Sky Visitor began trending worldwide. Theories stacked on top of theories. Some users claimed they'd seen the same object days earlier. Others posted blurry, unrelated photos of auroras, insisting it was all connected. That's how 3I Atlas, a quiet interstellar rock, became the internet's latest obsession. But the truth behind that light wasn't born in China's sky. It began much earlier, months before that viral video, in a small observatory on the island of Hawaii. The Atlas Project, short for Asteroid Terrestrial Impact Last Alert System, is designed to spot dangerous near-Earth objects before they get close enough to do damage. It's basically Earth's early warning system for incoming space debris. One night, while scanning routine coordinates, the team noticed a faint object moving in a trajectory that didn't match any known comet. Its speed was abnormally high and its direction completely off the standard orbital patterns we see from objects born in our solar system. They tagged it, logged the data, and at first it didn't seem special. Space is full of these icy drifters, but over time, 3I Atlas behaved strangely. Its brightness fluctuated, almost pulsed, in ways comets typically don't. Then just weeks before the viral video, the readings spiked. The comet had brightened exponentially, as if it had suddenly ignited. Astronomers call this a coma explosion. It happens when volatile gases trapped beneath a comet's crust heat up and burst outward, releasing dust and light. But in the case of 3I Atlas, the scale was extreme. It brightened by several magnitudes almost overnight. That's what made it visible to people on the ground, and why the footage from China spread like wildfire. When the first major observatories confirmed the object's coordinates, they realized something extraordinary. This wasn't an ordinary solar system comet. It wasn't orbiting our sun. It was passing through. That's what the 3I in its name stands for, interstellar object, meaning this thing came from outside our solar system entirely. Only 2 others had ever been discovered before it. The first was 1I Oumuamua, the elongated metallic-looking object that moved so fast it defied normal gravity models. The second was 2I Borisov, a more traditional comet made of ice and gas that zipped past the sun in 2019. Both stunned astronomers, proving that our solar system isn't isolated. Things really do wander in from the depths of other stars. And now 3I Atlas had joined that elite cosmic list. So why did it blow up online like this one did? Why did the world react to 3I Atlas with such shock and fascination when previous interstellar visitors barely made the evening news? Part of it comes down to timing and narrative. When Oumuamua was discovered in 2017, the internet wasn't quite as fast at turning scientific anomalies into viral mysteries. Borisov arrived quietly during the chaos of 2019 when global attention was on politics and pandemics. But 3I Atlas came in an era when every unexplained light instantly becomes a global talking point, amplified by millions of eyes, phones, and imaginations. Add to that a few coincidences. Chinese and Western space agencies had both been making announcements around deep sky exploration programs. Some even mentioned plans for long-range probes. So when a strange light appeared over China's sky, connecting the dots felt too easy. And yet, the raw data didn't lie. NASA's Jet Propulsion Laboratory quickly verified its path, hyperbolic, meaning it's not bound by the sun's gravity. It came in, swung by, and will eventually drift back into deep interstellar space, never to return. Its estimated speed, around 93,000 miles per hour. That's almost 40 times faster than a bullet. Its composition, according to early spectroscopic data, included traces of carbon, oxygen, and cyanogen, a bluish gas that gives it that ghostly green tint when it reacts with sunlight. That eerie color, part science, part beauty, is what made 3i Atlas look so mesmerizing in the videos. The combination of mystery, timing, and visuals turned a real astronomical event into a global spectacle, but beneath all that noise, a simple truth remained. We were watching something alien, not in the sci-fi sense, but literally. Something not of our solar system. Now, think about that for a second. A rock that formed around a different star, possibly billions of years ago, just happened to wander close enough for us to see it. Statistically, the odds are almost impossible. The distances between star systems are unimaginably vast. Even light takes years to cross them. Yet here it was, streaking across our sky like a visitor with no passport. When you really think about it, 3i Atlas is like a cosmic message in a bottle. A fragment of another world drifting through the black ocean of space, landing in our line of sight for just a brief, beautiful moment. No wonder people couldn't stop watching. Some saw wonder, some saw warning, and a few perhaps saw reflection, a reminder that Earth is just a speck floating in someone else's night sky. But there was another reason scientists became obsessed. Unlike Oumuamua, which was already fading fast when discovered, 3i Atlas was bright and active, meaning telescopes could actually study it in detail. Its tail, its gases, its spin, all offered precious clues about what interstellar material looks like up close. For researchers, it was like opening a time capsule from another solar system. Yet the comet's odd behavior kept raising questions. Its brightness didn't follow the typical fading curve. Its orbit showed micro-deviations suggesting non-gravitational forces, like jets of gas, were subtly steering it off course. These details matter because they hint at its structure, whether it's solid, hollow, or even breaking apart. And yes, this is the same kind of data that led some scientists to speculate that Oumuamua might have been something artificial, though most now agree that's unlikely. Still, the fact that 3i's Atlas arrived so soon after those previous interstellar visitors sent a chill through the astronomy world. 3 such events in less than a decade after millennia of silence. That's not luck, that's a pattern. So maybe the explosion wasn't just the comet's brightness. Maybe it was our own awareness, exploding open. Because every time we spot one of these cosmic nomads, we're reminded that our solar system isn't an isolated bubble. It's part of a massive interwoven galaxy full of wandering fragments that carry whispers of other worlds. And somewhere around another star, a different civilization, if it exists, might be watching one of our comets streak by and wondering the same thing. Where did that come from? So when people say 3i Atlas was just another rock, they're missing the bigger picture. This wasn't a random viral event. It was history in motion. A comet that crossed from one star's domain into another's. A celestial drifter that reminded billions of people, even for a moment, that the universe is far stranger, and far more connected than we often realize. And as 3i Atlas continued to blaze across our skies, scientists scrambled to study it before it vanished forever. Because once it's gone, that's it. No do-overs. It's the cosmic equivalent of catching a shooting star. You either see it or you miss it. In that brief window between discovery and disappearance, we glimpsed something extraordinary. A traveler from the stars, igniting both telescopes and imaginations. And that's how the story of 3i Atlas didn't just start. It exploded. The discovery nobody noticed. On the 1st July 2025, a robotic telescope in Chile called ATLAS, Asteroid Terrestrial Impact Last Alert System, quietly flagged an object moving through space. What it found didn't scream alarm or spectacle at first. It was just a faint point of light in the night sky, measured and logged. But within hours, data began to suggest otherwise. This wasn't your ordinary comet, asteroid, or near-Earth object. It was something else entirely. The telescope in Chile reported observations of the object, which soon earned the temporary designation C-2025N1, ATLAS. What raised eyebrows was the orbit. The object's path was hyperbolic. In other words, its eccentricity was greater than 1, meaning it wasn't bound by the sun's gravity like a typical comet or asteroid would be. It was passing through our solar system, coming from somewhere else. That's when astronomers applied the tag 3I, the third interstellar object ever confirmed. Coverage of the discovery notes that follow up images, including archival pre-discovery frames, extended back into June 2025. These pre-discovery observations allowed astronomers to refine the trajectory, confirming the unusual speed on the order of 60 cone and origin outside the solar system, because most objects in our solar system move far slower and on closed orbits. At first, most people missed this story. Observatories and astronomers quietly shared data. Scientists clocked it, dug into historical images, checked catalogs. The public, meanwhile, had no idea the cosmic stage was being set, because although the numbers were strange, visually the object looked unremarkable. A small dim speck, faintly fuzzed by a hint of coma dust, nothing like the bright comets you see in newspapers. By the time larger instruments were pointed at it, like the Hubble Space Telescope, which imaged the object, revealing a teardrop-shaped dust envelope around a compact nucleus, the narrative had already shifted. This was not just another comet. This was a visitor from another star system. And that realization quietly bubbled through scientific channels. But the phrase "quietly" is key here. Unlike comets that burst into bright visibility, this interstellar traveler didn't demand attention. Not yet. And yet its discovery ranks among the rarest. Only 2 other interstellar objects are known. Oumuamua in 2017 and Borisov in 2019. That means 3I Atlas gave us only the 3rd opportunity ever to observe material formed in another star system. Here are some key facts from the discovery stage. The object was first reported at an approximate distance of 4.5 AU, 670 million kilometers from the Sun. Its inbound path was traced from the direction of the constellation Sagittarius or nearby, implying a route seldom used by typical solar system comets. At discovery, its brightness was faint, magnitude -18, too dim for naked eye viewing. Only powerful survey telescopes caught it. Pre-covery images from archive telescopes extended its observed arc, giving scientists the ability to refine the hyperbolic orbit and rule out a solar system origin. These pieces made the discovery remarkable, but they also raised deep questions. What kind of object is this? Where exactly did it come from? How was it made? Because the population of interstellar objects is extremely tiny, our detection of them is still new, and each one teaches us something unexpected. In fact, one of the earliest scientific write-ups described 3I Atlas as very likely to be the oldest comet we have ever seen. The reasoning: objects that have wandered in interstellar space wear cosmic scars, exposure to galactic cosmic rays, dust impacts, radiation over billions of years. If 3I Atlas is one such wanderer, it might preserve states of matter rarely seen in our own solar system. For you as a viewer and enthusiast, this moment, the discovery phase, is hugely significant. It reminds us that our solar system is not isolated. We often think of comets as part of our system, but here's one that isn't. It invites us to ask, how common are such interstellar visitors? What do they carry? And could they bring us preserves of other star systems' chemistry? Also, the fact you might see this object in upcoming months or see its data released means you are part of this story, not just the scientists. Because when an interstellar object swings by, the observing window is limited. That means every data point, every image, every spectrum matters. So the discovery period might not have been flashy, but it's foundational. Without it, we wouldn't be able to frame the rest of the story. The viral footage, the controversy, the chemistry, the mission proposals. Without that quiet moment in a Chilean survey telescope's log, 3I Atlas would have just been another passing comet. Instead, it became a visitor, and visitors changed the game. In the next section, we'll explore how this quiet discovery turned viral. How a short video upload and social media firestorm propelled 3I Atlas from scientific footnote into global phenomenon. We'll look at how the image footage spread, what it showed, and why people began asking bigger questions. The video that started it all. For weeks after the discovery, 3I Atlas was mostly a whisper in scientific circles. A few observatories tracking it, a handful of astronomy subreddits buzzing quietly. Then one clip changed everything. Late in July 2025, a night sky watcher from China uploaded a short, shaky phone video to X, formerly Twitter. The footage showed a glowing blue-white streak moving slowly across a hazy sky. What made it unsettling wasn't the motion itself. Comets do that, but the way the object pulsed. Every few seconds, the light brightened and dimmed almost rhythmically like a heartbeat. The video was captioned simply, "What is this above Chongqing?" Within hours, it had millions of views. People began reposting it with every possible label. UFO, missile test, secret satellite, alien beacon. Others zoomed in on frames and claimed to see geometric reflections. Some even drew flight paths over maps of China, tracing imaginary invasion routes. It was the perfect storm, a real astronomical event filmed in dramatic conditions, landing in the middle of the internet's rumor mill. But here's the twist. Scientists quickly confirmed the object was 3I Atlas. The comet had brightened dramatically, roughly 100 times more luminous than it had been at discovery. Its color, too, shifted toward electric blue, a hue rarely seen in comets at that distance from the sun. The blue glow wasn't artificial light. It was caused by ionized carbon monoxide, CO+, and cyanogen, CN, gases fluorescing under solar ultraviolet radiation. Essentially, sunlight was charging the gas molecules like neon signs. But that explanation didn't travel as fast as the video. For casual viewers, the light seemed too steady, too symmetrical. It didn't tail off like a typical dusty comet. Instead, it appeared spherical, almost plasma-like. Amateur astronomers scrambled to confirm the view. Telescopes from Korea, Japan, and India soon recorded the same object, noting a bizarrely symmetrical coma and no visible dust tail. Behavior that set 3I Atlas apart from ordinary solar system comets. Let's unpack that. Most comets heat unevenly. Ices evaporate, gas jets shoot off, and the nucleus tumbles, creating tails that stretch millions of kilometers. 3I Atlas, by contrast, looked more like a slow, spinning globe of blue gas. That smoothness fueled endless speculation. Was it rotating unusually slowly? Was it breaking apart? Or was its structure simply different because it came from another star system? Even mainstream science outlets joined the discussion. Astronomers from the European Southern Observatory confirmed a fast brightening event, inconsistent with solar heating alone, suggesting internal volatile materials, possibly CO2 ice, were suddenly venting. In simpler terms, it popped like a shaken soda bottle under sunlight. The blue glow wasn't mysterious after all, but the timing was uncanny. It happened right as the viral clip hit social media. You can imagine how that timing looked online. Conspiracy accounts claimed the flare was a response to Earth radar signals. A few even said it was changing color intentionally. Hashtags like #BlueComet and #AtlasVisitor trended for days. People asked whether China had discovered it first, or whether NASA was hiding its true nature. The blend of awe and fear made 3I Atlas a digital ghost story. Behind the noise, scientists raced to collect real data. Spectroscopic readings showed emission bands of CN and C2, confirming genuine cometary gas. Still, one number kept popping up. The CO2 to H2O ratio seemed unusually high, almost 8 to 1, suggesting this visitor carried far more carbon dioxide than typical solar system comets. That's like comparing an Antarctic iceberg to a carbonated drink. The chemistry hinted at a birthplace in a much colder, perhaps younger star system. Think about that. A fragment formed around another sun billions of years ago, now crossing our sky and accidentally lighting up smartphones across Earth. It's cosmic irony at its best. Interstellar archaeology turned social media event. And here's the human side. While debates raged online, observatories from Beijing to California began pooling their measurements. In a rare show of cooperation, both Chinese and Western scientists contributed photometric data to refine its orbit. The more they calculated, the clearer it became that 3I Atlas was indeed interstellar. Not a returning fragment or space debris. It was moving far too fast, nearly 67 kilometers per second relative to the sun, to ever be captured again. The viral video, though, had already taken on a life of its own. Memes, reaction videos, expert breakdowns, even pseudo-documentaries flooded YouTube. One popular post asked, "If it's from another star, could it be sending a message?" Another replied, "Maybe the message is, look up more often." You, as a viewer, might ask the same. Why do we notice the universe only when it glows blue and trending? What else passes quietly over our heads that never makes a headline? In hindsight, that first clip from Chongqing did more than spark panic. It turned 3I Atlas into a symbol of how science meets culture, how fact collides with fascination. A tiny comet, unseen for eons, became the canvas for human imagination. As the noise settled, astronomers got back to their instruments. They traced its trajectory, analyzed its chemistry, and prepared for what came next. The moment governments, media, and agencies began to stake claims and shape narratives. Because when something from another star enters your sky, it's never just about science anymore, China steps in. When the blue glow of 3I Atlas swept across Chinese skies, Beijing didn't deny what people saw. They didn't confirm much either. And that silence, it was gasoline on the fire. In early August 2025, Chinese state outlets began covering the comet. Carefully, almost poetically. They called it a celestial visitor from beyond the stars and praised the public for capturing it so vividly. No words like threat, UFO, or probe, just quiet fascination. But to the international audience, that restraint sounded suspicious. Western tabloids immediately filled the gap with wild claims. China's secret space object, Beijing tracks alien craft, and Deep Sky Project targets interstellar visitor. Let's rewind for context. Around that same time, China's national astronomical observatories had been testing a new deep sky survey network, an array of powerful optical and radar systems designed to scan near-Earth objects and interstellar trajectories. So when reports surfaced that Beijing's Fast Radio Telescope and Chang'e mission teams were monitoring 3I Atlas, Many assumed it wasn't coincidence. Was this routine observation or something more deliberate? Then whispers started circulating on Chinese social platforms, screenshots claiming that a classified research mission was approved to study the object. No official record, of course, but that's how rumors thrive, in the gaps. Western intelligence analysts reportedly flagged increased telemetry traffic between Chinese tracking stations. Add a few mistranslated Weibo posts and suddenly you've got the internet believing China had launched a probe to intercept an alien comet. In reality, what likely happened was far more mundane and far more interesting. Chinese observatories, including Purple Mountain and Xinglong, did begin coordinated tracking to analyze the comet's spectral fingerprint, essentially the light signature that reveals its chemical composition. They weren't sending rockets after it. They were collecting data, and good data at that. But once the idea of a Chinese probe hit Western feeds, the story spiraled into geopolitical theater. CNN and Sky News ran segments titled "China's Race for the Alien Comet," while commentators framed it as the next frontier of the US-China rivalry. One American host asked, "If it's really interstellar, whoever gets to it first gets first contact, or first tech." It sounded absurd, but that's what makes it captivating. To space watchers, though, something was intriguing about China's approach. Instead of outright denying conspiracy chatter, they leaned into the science. The Chinese Academy of Sciences released raw spectral data from early August, a rare move in a field where nations usually keep tight control. Their readings confirmed high carbon monoxide emissions and a strange cyanogen spike, the same findings Western teams would later echo. Whether intentional or not, China's quiet transparency gave them an upper hand in credibility. They looked calm, methodical, almost prophetic. Still, some saw that calm as calculation. If you listen to how the Chinese coverage framed it, they never once called 3I Atlas a comet. They used the term interstellar body, neutral, but vague enough to make imaginations run wild. Even in press briefings, officials avoided definitive labels as if leaving the door open for the mysterious. To their audience, it was wonder. To the rest of the world, it sounded like a smirk. Here's where things turned cinematic. A small aerospace company in Shenzhen hinted that they had proposed a micro-probe intercept for educational research. Just a concept, no funding, no mission. But the internet treated it as fact. Threads exploded with titles like "China is sending a probe to an alien object." The myth was alive and moving faster than the comet itself. Meanwhile, the West responded predictably. NASA, ESA, and private space firms began running feasibility simulations. How fast would a spacecraft need to travel to reach 3I Atlas before it left the solar system? The short answer, impossibly fast. By the time any probe launched, it would already be gone. Still, that didn't stop headlines like US scientists plan interstellar pursuit mission. The race existed mostly on paper, but in public imagination it was real. Here's the fascinating irony. Amid the drama, both China and the US were actually sharing observation data through open channels like the Minor Planet Center. Astronomers on both sides of the Pacific were comparing notes on brightness curves and orbital changes. Science quietly doing what politics couldn't, cooperating. But perception is everything. On Chinese social media, patriotic hashtags like #ChinaSkyVisitor and #RStarGuest trended for days. On the Western side, it was #Alien Probe and #Atlas Threat. Same object, two completely different emotional universes, one seeing beauty, the other danger. And maybe that's the real story here. When space becomes political, truth becomes classified. Every frame of that blue glow gets filtered through fear or pride, curiosity or control. The sky stops being neutral. It becomes a mirror reflecting how divided we are beneath it. So what was China really doing? Probably what every other spacefaring nation was doing. Looking up, gathering data, chasing the unknown. But the way they handled it, with a mix of scientific confidence and poetic ambiguity, made the whole world wonder if they knew something the rest didn't. Because in a world where one glowing rock can spark a global frenzy, silence can sound a lot like a secret. Next, how the Western panic began, and why the same comet that inspired awe in one hemisphere ignited paranoia in the other. The Western panic. By the time the news reached Western shores, 3I Atlas wasn't just a comet. It was a storyline, a mystery threaded through science, politics, and fear. It had already been called a foreign object, a metallic visitor, and even a message from another civilization. And like all great mysteries, it didn't need proof. It only needed timing. NASA's first public acknowledgement came in early August 2025. A short, almost routine statement confirming that interstellar object 3I Atlas is being actively tracked by multiple observatories. It should have calmed things down. Instead, it poured gasoline on a fire that had already gone viral. The words interstellar and object appeared side by side, and the internet did what it always does best: fill in the blanks. Reddit threads lit up overnight. X, formerly Twitter, buzzed with grainy sky clips from Arizona, Rome, Tokyo, each claiming to show the same blue flickering in the night sky. YouTubers ran wild with thumbnails screaming, "Alien technology," and "NASA hiding the truth." Conspiracy influencers began claiming that 3I Atlas wasn't following a purely gravitational path, that its trajectory subtly adjusted itself, as though under intelligent control. The same words that were once used about Oumuamua back in 2017 resurfaced like ghosts: artificial, probe, beacon. Inside the scientific community, that rumor hit a nerve. After all, this wasn't the first time an interstellar visitor had made headlines, but this one was brighter, bluer, stranger. Its light curve, the graph showing brightness over time, didn't behave like most icy comets. It pulsed, not rhythmically, but unpredictably. Some thought it was dust jets, others blamed solar radiation or tumbling rotation. But in the vacuum of certainty, imagination takes over. NASA's Jet Propulsion Laboratory, JPL, tried to ground the discussion. They released the object's updated orbital data: high speed around 63 km, perihelion distance roughly 0.2 AU, and absolutely no threat to Earth. But who listens to data when mystery sounds more exciting? Even the mainstream media caught the fever. CNN's science segment ran with "alien probe or natural visitor." Fox News used China, comets, and cosmic secrets. It was half fact, half theater, and it worked. Every headline added another layer of anxiety. Suddenly, this lonely rock from another star system became the mirror reflecting humanity's biggest fears: secrecy, rivalry, and the unknown. Meanwhile, on YouTube, podcasts, and late-night radio, a new narrative took shape, one that questioned whether NASA was hiding something. Clips began circulating claiming NASA's live stream had cut out mid-observation, that a hexagonal shimmer appeared in one of the telescope feeds. Completely unverified, of course, but that's never stopped a good rumor before. The European Space Agency tried to balance the noise by publishing early compositional data. The comet was rich in CO2 and water ice, Nothing extraterrestrial about that, at least not in the sci-fi sense. But then came that unexpected curveball, the blue hue. When telescopes picked up the color shift as the comet brightened, people stopped listening to scientists and started listening to storytellers. "Comets don't just turn blue," said one viral post, "unless they're burning something unnatural." By this point, even NASA's calm tone couldn't compete with the drama unfolding online. "We are observing a fascinating interstellar object," said Dr. Thomas Zurbuchen in a televised panel. "Its properties are unusual but consistent with natural explanations." But natural explanations rarely trend. Amid all the noise, a few astronomers began defending the science with quiet determination. Dr. Karen Meach, who had worked on the study of Oumuamua, reminded everyone that weird doesn't mean artificial. If you spent billions of years drifting through deep space, cosmic rays would carve your surface, mix your elements, and make you glow in strange ways too, she said. But to a public primed for drama, cosmic rays didn't sound as thrilling as alien signals. Even private space companies got involved. Elon Musk joked about sending a Tesla to chase it, and Virgin Galactic posted an image captioned, "Interstellar tourism starts here." For a few days, 3i Atlas became pop culture's new obsession. Part science, part meme, part existential question. And then the light started flickering again. As the comet moved closer to the sun in late September, its brightness fluctuated sharply. Bright one night, dim the next, then suddenly bright again. Scientists called it volatile outgassing. The internet called it communication. Videos comparing the pattern to Morse code or binary signals went viral. And while astronomers patiently explained sublimation dynamics, the process of frozen gases turning into vapor, hardly anyone cared. The mystery was simply too entertaining. Still, something about the pattern was odd. The outburst didn't fit the typical timeline for solar heating at that distance. It wasn't proof of anything artificial, but it was undeniably strange. And strange is all it takes to keep curiosity alive. Behind the headlines, the world's telescopes were in full swing. NASA's James Webb, the European Very Large Telescope, and Japan's Subaru Observatory all focused their instruments on 3i Atlas. Even China's Fast Radio Telescope joined the effort, though it didn't detect any radio emissions. For a brief moment, the entire planet was staring at the same icy traveler, divided by politics, but united in fascination. By October, the panic had reached its peak. "Could this be a test run?" asked one viral documentary. "Something scouting Earth's defenses?" It was sci-fi masquerading as science, but it fed an ancient instinct, the fear that we're not alone, and worse, that we might not be ready. In truth, NASA's data was clear. The comet wasn't slowing down, wasn't steering, wasn't communicating. It was just leaving. Yet in that quiet fact lies something deeply unsettling. That something from beyond our solar system came, flared briefly in our skies, and disappeared before we ever really understood it. And maybe that's what drives the panic. Not the idea that 3i Atlas is an alien probe, but the fear that it could be and we'd never know. Because here's the haunting thought. If something truly intelligent were passing through, would we even recognize it before it was gone? Next comes where the story turns cosmic again. Where 3i Atlas is now, what scientists are still finding, and why this visitor might be more than a comet, even if it's not what the panic imagined. Where it is now, right now, Comet 3i Atlas is drifting through the outer reaches of our solar system. A faint traveler heading back toward the cold dark between the stars. Telescopes around the world have been tracking it, And here's where things get fascinating. Its brightness has been fading, yes, but not in a normal, predictable way. Instead, it pulses like a heartbeat. Some astronomers noticed that the comet's glow fluctuates every few days, hinting that it might be rotating unevenly or breaking apart internally. That's not unheard of. Many comets tumble as they heat up near the sun, but 3I Atlas seems to be doing it differently. Its tail, for example, has a weird chemical signature. Observatories like the Nordic Optical Telescope and the Lowell Observatory detected traces of cyanide and diatomic carbon, standard stuff for comets, but also faint signals of metals and silicates in odd proportions. Think of it like tasting soup and realizing someone used ingredients that don't belong in the recipe. When it passed closest to the sun earlier this year, something else caught attention. It changed color. Most comets go from icy white to a yellowish haze as they shed dust and gas. But 3I Atlas briefly glowed bluish-green, then shifted back to pale white as it moved away. That might sound minor, but color changes like that often mean a rapid chemical reaction or solar radiation altering its surface materials. In other words, space weathering on steroids. Now it's moving away on a hyperbolic path that ensures it'll never return. Its current speed is estimated to be around 60 kilometers per second, fast enough to escape the sun's gravity entirely. Once it leaves our neighborhood, that's it, gone. Scientists are scrambling to gather as much data as they can before it fades completely from our reach. What's wild is that even now, the comet's gas emissions don't line up perfectly with its predicted rotation. That suggests its shape might be irregular, maybe even hollowed or fragmented. Some models suggest it could be two bodies loosely bound together, slowly spinning apart. Others think the odd light flickers could come from highly reflective patches like metallic surfaces catching sunlight. And here's where speculation sneaks in. Because every time humans find something we can't perfectly explain, imagination fills the gaps. Could 3I Atlas be a shard of something ancient? Maybe an interstellar asteroid broken off from a dying system? Or, as some have dared to whisper, could it be artificial? A remnant of a long-lost civilization silently crossing the void? We don't have proof of that, of course, but here's the haunting truth: we might never know. It's already too far for any spacecraft to reach in time, and soon it'll slip into the darkness where no telescope can follow. So next time you look up at the night sky, remember this. Somewhere out there, that little comet, our brief visitor from another star, is still moving, carrying secrets we didn't have the tools to uncover. And who knows, maybe it's not the last traveler we'll see. Maybe the next one won't just pass by. Maybe it'll stop and look back. The mission race. The moment astronomers confirmed that 3I Atlas wasn't just another icy rock but an interstellar object, the question spread through every space agency on Earth like wildfire. Can we reach it? Can we actually send something out there before it vanishes forever? That's where the so-called mission race began. China, the United States, and the European Space Agency each started quietly running simulations. The Chinese Academy of Sciences hinted that their Deep Sky program, a long-term mission to study small bodies and asteroids, might pivot to include a flyby attempt. They've already proven they can do fast, ambitious missions. Remember Chang'e 5, which brought lunar samples back? Their engineers know how to move fast when a window opens. Meanwhile, NASA had its own theoretical plans on the table. The Comet Interceptor mission, originally meant for an undiscovered long-period comet, suddenly looked like the perfect tool for something like 3I Atlas. But here's the problem: timing. Even if you launch tomorrow, the comet is already moving away at breakneck speed. The kind of intercept trajectory needed would require technology we just don't have yet, or an enormous amount of fuel that would make the mission wildly expensive. Still, scientists hate letting mysteries drift away. There were whispers in astronomy circles that private space companies like SpaceX or Rocket Lab could attempt a micro-probe launch, leveraging reusable rockets to cut down on time and cost. Rocket Lab, for example, has already announced missions to Venus, so aiming a small probe at a fast-moving interstellar object isn't totally insane, it's just barely possible. But beneath all that science talk, there's a different tone, a quiet urgency. Because whoever gets there first, even with just a few images or samples of gas from the tail, could change everything. Think about it. If we touch something that was born around another star, we'd be holding material from another solar system. That's not just a science headline. That's cosmic archaeology. Of course, this also stirs competition. Space exploration isn't just about discovery anymore. It's about prestige, politics, and power. China reaching 3I Atlas first could cement its place as the new space leader. The US getting there first could mean owning the narrative and the data. But here's the catch. The window is closing fast. 3I Atlas is already heading out toward the edge of our detection limits. Every day it moves farther, fainter, colder. Even radio signals bouncing off it grow weaker. So the race isn't really between countries. It's between humanity and time itself. Can we act fast enough to reach something that doesn't care if we do? Or will it simply vanish, taking its secrets back into the void? And that's the real tension. The idea that somewhere out there is an answer to a question we're too slow to ask. The bigger question, when you strip away the noise, the viral clips, the debates, the wild theories, what's left is a single haunting question. What is 3I Atlas trying to tell us? See, every interstellar object that's ever visited us, and there've only been 3 we know of, has carried a kind of message, not in language, but in form. Oumuamua looked like a metal shard spinning like a lost artifact. Borisov was a classic comet, quiet and cold, but 3 Atlas? It's weirdly in between. It acts like a comet but shines like a metallic reflector. Its path doesn't match gravitational predictions perfectly. It's like the universe is teasing us with something that doesn't fit neatly into our textbooks. And that's what drives scientists crazy and fascinates everyone else. Because deep down, we're not just studying rocks and dust, we're searching for mirrors of ourselves. If something crossed billions of miles of empty space to end up here, what are the odds that it's just random? Maybe 3I Atlas isn't a threat, or a probe, or even a comet in the traditional sense. Maybe it's a messenger, a fragment of something ancient, a survivor of another world's birth or death. When you think about it, it's poetic. While nations argue about who might reach it first, the comet itself couldn't care less. It just glides on, steady and silent, as if mocking our noise. And yet, it's teaching us something profound. How quickly humanity turns mystery into fear. How curiosity can fracture into competition. How every glimpse into the unknown shows us more about us than about the universe. But maybe, just maybe, that's the point. Maybe these interstellar wanderers are not just visitors. They're reminders that we're not alone in motion, not alone in mystery, not alone in asking the biggest question of all. What else is out there? As 3I Atlas fades into the dark, it leaves behind no answers, only wonder. And sometimes wonder is the most powerful thing the universe can give us. CO2 overload, what 3I Atlas's chemistry reveals about other star systems. Picture this. You're holding a message in a bottle, not washed up on a beach but drifting through the darkness of space. That message, the chemical fingerprint of 3I Atlas, and scientists just cracked it open. When the James Webb Space Telescope focused on 3I Atlas in early August 2025, what it found stunned astronomers. The comet's coma, the halo of gas and dust around it, was dominated by carbon dioxide to an extreme degree. The ratio of CO2 to water came in around 8:1, one of the highest ever recorded for any comet. Most comets we know from our solar system are water-rich. As they heat up, frozen water turns to vapor and forms those classic glowing tails, but 3I Atlas, it's acting like a stranger from a colder, darker world built more from carbon than from water. This means one of two things. Either the comet's nucleus naturally formed in a region of space overflowing with CO2 ice, or the water is trapped beneath a crust so dense that carbon dioxide, being more volatile, escapes first. Both possibilities point toward an environment far different from the one that shaped the comets we grew up studying. Here's where the mystery deepens. If 3I Atlas was born in another star system, its chemistry becomes a direct sample from that alien nursery. Maybe it formed near what scientists call the CO2 ice line of its parent star's disk, the region where carbon dioxide freezes instead of water. Or maybe it wandered in interstellar space for billions of years, bombarded by cosmic rays that changed its chemistry molecule by molecule. Researchers even estimate that its outer layers could have been altered by radiation to depths of tens of meters, essentially creating a crust of cosmic scars. Why does that matter? Because this isn't just about a single comet. It's about rewriting what we think planetary systems can look like. If this visitor from another star carries a chemical balance unlike anything we've seen, maybe our solar system is the oddball, not the standard. Imagine whole worlds forming where carbon dioxide dominates, where water is rare, and where the building blocks of life start from an entirely different recipe. Ask yourself this: what if 3I Atlas isn't just a piece of rock and ice, but a clue to how alien solar systems breathe, burn, and build planets? That CO2 ratio isn't just a number. It's a cosmic accent, a reminder that not every system speaks the same chemical language as ours. Of course, not everything is confirmed. Some of the data are still being analyzed, and scientists remain cautious. Water, carbon monoxide, and other gases were detected too. It's no alien spacecraft, just a profoundly strange visitor. But even so, it stretches our imagination about what's possible out there. So as 3I Atlas continues its long flight out of the solar system, think of it as a messenger passing through. Its chemistry is a whisper across the stars: I came from elsewhere. I'm built differently, pay attention. For anyone who loves space, that's pure gold, because every molecule of this comet tells us something about another world, one we'll probably never see, but that once, just for a moment, sent a frozen ambassador our way. Surface scars of a billion-year journey. Imagine a comet that's not just drifting through our solar system, but one that has survived the galaxy. That's what 3I Atlas appears to be, a cosmic wayfarer with scars. Not just from its home star, but from its long voyage between stars. The first hint of this story comes from what astronomers call polarimetry, the measure of how sunlight scatters off dust and ice around the comet. The recent study shows that 3I Atlas East displays a highly negative polarization branch, down to 2.7%, at very small phase angles and an inversion angle of 17 degrees. These values are unprecedented among comets or asteroids we've seen. In plain terms, the dust and ice grains around this object reflect light in a way that doesn't match anything in our solar system. It behaves more like icy bodies out beyond Neptune, objects that have been hanging in the cold dark for eons. That tells us something powerful. The surface and coma of 3I Atlas has likely been heavily processed by galactic cosmic rays and radiation, not just solar heating. In interstellar space, away from a protective heliosphere, particles bombard icy bodies for millions or billions of years. That kind of exposure can change surface chemistry, darken materials, restructure dust grains, and that's exactly what we might be seeing. Then there's the chemical story. Spectral data indicate a coma dominated by carbon dioxide with a high CO2-H2O ratio, 8:1. Water ice is present but suppressed relative to CO2. Why might that be? One scenario, the comet formed near a CO2 ice line in its parent star system, so it started off with lots of CO2. Or the water might lie beneath a refractory crust so thick that solar heating can't reach it easily, forcing CO2, which sublimates more easily at greater distances, to dominate. Either way, this object isn't behaving like a newly born comet from the Oort cloud. It's old and weathered. Here's the dramatic part. If 3I Atlas has been traveling between stars for eons, it may carry matter from a star system long gone, or at least evolved far differently than ours. That means its surface is a living memory of that journey. Icy grains altered by cosmic rays, volatiles depleted or enhanced, dust built differently. Observing it is like reading the weather history of another star system. So what does that mean for you, the enthusiast? First, you're not just watching a fly-through visitor, you're witnessing a survivor, a body that has endured far more than a typical solar system comet. Second, the data gives us a chance to compare not just how comets in our system behave, but how comets from other systems behave. It flips the conversation from our comet versus yours to our system versus theirs. Third, it reminds us that the galaxy is vast and dynamic. Objects don't just orbit one star and die. They get launched, wander, scratch their surfaces in radiation fields, and end up here telling us silent tales. Ask yourself, if a comet can carry the scars of a billion-year journey, what else might it carry? Where did it come from? What star launched it? That built-in mystery is what makes this section so potent. The otherworldly behavior isn't flashy, it's subtle. It's the slow grind of cosmic time turning ice to dust, grains to aggregate, comas to ghost trails. Light tricks and weird polarization. When 3I Atlas entered our solar system, it behaved like a comet, glowing, shedding material, forging a tail. But the light it reflected, that's where things got weird. Telescopes around the world measured how sunlight scatter reflected off its dust and gas envelope, the coma. What they found was unexpected. At very small phase angles, the angle between the sun, the comet, and Earth, 3I Atlas exhibited an unusually strong negative polarization of about 2.7%. That number might sound technical, but here's the translation. When most comets or asteroids reflect sunlight, the light becomes polarized in a particular pattern. This one flipped the pattern into a zone unseen in our solar system. On top of that, the inversion angle, the transition point where polarization changes sign, came in around 17 degrees. That combination, deep negative polarization plus a narrow branch at small angles, is unprecedented. It suggests the dust and ice particles around the comet are shaped, structured, or composed differently than any we've studied so far. Why does that matter? Because polarization gives clues about what the surface is made of, how its particles are arranged, and how light interacts with them. The unusual readings point to particles that might be very porous, allowing light to bounce in weird paths unusually large or irregular in shape, coated or mixed with materials altered by long exposure to space radiation. In short, the light is telling us this visitor isn't just another comet. It's got a texture, a story, and potentially an origin far different from the ones we're used to. Couple that with the fact that the visible spectrum of 3I Atlas shows a slightly reddish-orange slope, more akin to trans-Neptunian objects or centaurs than typical inner solar system comets, and you get a picture of something built in another environment then battered across space. Here's a question for you. If the light signature of a comet tells us about its dust and ice microstructure, what if that signature says alien star system rather than just our backyard? That's the kind of story 3I Atlas is writing. Now, before you slide into sci-fi mode, there's an important caveat. None of this proves non-natural origin, not even close. The comet still fits within the broad behaviors of icy bodies, just on an extreme edge. But the edge is exactly what makes it interesting. It forces scientists and space enthusiasts like you to ask, how many comets have we missed that behave this way? What if our solar system's comets are the norm and visitors like this show us alternate histories? As 3I Atlas moves farther from the sun and our telescopes lose resolution, these polarization and light scatter data become prime treasures because we might never get another view like this of the same interstellar object. So every measurement, every odd dip in brightness or odd color flash becomes part of the dossier. In the next section, we'll move into how 3I Atlas's tail, its shape, its materials, is changing as it crosses the sun and what that might reveal about its internal structure, its fate, and maybe even its origin. The tale that's trying to tell us. When 3I Atlas first entered our view, its tail barely seemed to exist, just a faint glow of gas and dust surrounding its nucleus. But as it drew nearer to the sun, the story of its tail shifted dramatically and weirdly. Ground-based telescopes, including the International Gemini Observatory in Chile, captured images in late August 2025 showing the comet developing a broad coma and a tail stretching tens of thousands of kilometers. Observers noted that this tail pointed away from the sun, what makes sense for a typical comet as solar radiation pushes dust outward. But then came the curveball. At earlier stages, 3I Atlas showed what's described as an anti-tail, a feature that appeared to point toward the sun. Why is that strange? Because in a standard comet scenario, the solar wind and sunlight push dust grains and ionized gas outward, forming a tail that trails behind the object and away from the sun. But in 3I Atlas's case, large dust particles may have been ejected predominantly toward the sun-facing side, forming a fan or plume that appears sunward. Some models suggest the dust grains are large, millimeter-sized, a size that makes them less responsive to solar radiation pressure, so they don't stream away immediately. They lag, clump, or create structures unusual for typical comets. The key data. The tail measured about 30 arc-seconds on the order of 50,000 pounds, 60,000 kilometers in scale in the images from August. The shift from a sun-facing dust plume anti-tail to a more familiar anti-solar tail happened as 3I Atlas moved closer to the sun and its activity increased. The coma size and tail length both grew quickly as the object neared perihelion, showing that its activity was rising faster than many comets at similar distances. So what does this odd tail behavior tell us, beyond the tail's weird? A few things. First, the size, velocity, and composition of ejected particles are unusual. Large particles mean slower response to radiation. That in turn suggests the surface or near-surface materials of 3I Atlas behave differently than those of typical comets. Perhaps because of its interstellar journey. Perhaps because its formation environment was very different. Second, the orientation and evolution of the tail provide clues about the internal mechanics of the comet. The transition from sun-facing plume to anti-solar tail could mean the comet's rotation, insulation layer, or activity mechanism is unconventional. Maybe the volatile materials, gases that sublimate, are buried beneath a crust and only activate when sunlight reaches certain regions. Third, this tail behavior is part of the larger puzzle about what 3I Atlas is and where it came from. When a comet behaves outside the norm, it invites fresh questions. Was the structure altered in interstellar space? Did it lose fine dust particles earlier in its journey, leaving only coarse ones now? Was it born in a region where dust and ice grain distributions differed markedly from our solar system? For you watching this as an enthusiast, this is the moment where you realize you're not just observing a passing rock. You're watching a dynamic system change in front of us, materials activating, surfaces shifting, dust streaming. And that gives you a front row seat to planetary science in motion. Ask yourself, what's inside that tail? What does the size and direction of those dust grains tell us about its past? As 3I Atlas passes perihelion and starts moving outward, the tail will fade, the particles will disperse, and the comet will slip back into the distant darkness. But for now, the tail is shouting at us, if we've learned how to listen. The comet is fading now. The once bright wanderer that made headlines, split opinions, and filled our night skies with wonder is dissolving back into the ink of space. For a few weeks, 3I Atlas burned across our imagination like a rumor from another galaxy. Now it grows dim, just another speck moving outward into silence. But that silence feels loaded, doesn't it? As if it knows something we don't. Think about it. This was only the third interstellar visitor humanity has ever confirmed. It traveled for millions, maybe billions of years before brushing past our tiny world. And in that blink of time, it left behind more questions than answers. Astronomers tracked it. Governments speculated, and people on social media filled the void with stories. Yet for all the talk, none of us can say for sure what it really was. Just a fragment of ancient ice, a messenger from a shattered system, or something meant to be seen, like a flare across the cosmic sea reminding us that the universe doesn't revolve around our curiosity but thrives because of it. Every frame of video, every telescope image, every whispered debate about its tail or color, all of it adds up to something rare, collective awe. That's the real discovery here. For a moment, people across continents looked up instead of down at their screens. They searched the same patch of sky. They asked the same question, what is that? And in that question, we were briefly united by something older than politics, older than fear. Wonder itself. Imagine where it's going now. 3I Atlas is slipping past the orbits of the outer planets, moving into a region of sunlight so thin it might as well not exist. Out there, temperature loses meaning, time stretches, and all that remains is motion. If you could ride alongside it, you'd hear nothing, only the whisper of particles left in its wake. It's heading home, or maybe nowhere at all. And maybe that's the point. Some scientists say the tail of a comet is like a diary written in dust, a record of everything it's been through. If that's true, 3I Atlas carries with it the memory of two star systems. The one it left behind and ours. It has tasted two suns, two gravitational wells, two civilizations that stared up in awe and confusion. Few objects in existence can claim to have crossed that kind of boundary. That's not science fiction. That's science doing its best impression of poetry. And as it goes, it leaves us with a quiet challenge. We spend billions searching for life beyond Earth, sending probes and signals, asking the void to talk back. But what if the universe already answered, just not in a language we were ready to hear? Maybe this comet isn't a messenger in the literal sense, but a reminder that the cosmos is alive with motion, and our job is to keep watching, keep asking, keep feeling small in the best possible way. Look up tonight, even if you can't see it. Somewhere beyond Jupiter, that faint trail of dust is still catching the last glint of sunlight, a goodbye shimmer from a traveler we'll likely never meet again. It's out there, marking this era of human history with a single fact. We noticed, we saw it, and for a little while we cared enough to wonder, because that's what it means to be human, to chase the unexplainable, to love the questions more than the answers, and to find beauty in the fleeting things that remind us how big, how impossibly big, this story really is. So before this chapter closes and the comet drifts into the dark, let's leave with one thought. Maybe the next interstellar visitor won't just pass us by. Maybe it will find us ready, scientifically, spiritually, imaginatively, to understand it. If you've come this far in the story, don't let it end here. Hit that subscribe button, join the channel, and keep your eyes to the stars, because somewhere out there, in the quiet between galaxies, something else is already on its way.